Okay, welcome Roxy and Jack and Marina and Marquette and Denise and Sophia, Liz and Jacqueline. Thanks for coming. We will jump right to the quiz. Okay, so here's the quiz. And it says the average newborn breastfed baby drinks 25 ounces of milk each day. A researcher wants to see if this average is lower for newborn breastfed babies if the mother lives below the poverty level. The researcher observes 41 newborn breastfed babies whose mothers live below the poverty level. They averaged 23.8 ounces of milk consumed, and their standard deviation was 7 ounces. So notice that 23.8 is less than 25, but that's not enough to immediately just say that, yeah, it's less, because we only have a survey of 41 or a sample size of 41. So part A is state the null and alternative hypotheses for the corresponding hypothesis test. All right, so when you have the null hypothesis, what are the first few symbols of the null hypothesis? For every null hypothesis that we ever do. How does it start?
H null and H1.
Yeah, so we go, well, for the null hypothesis, just H naught. Okay. And you choose, maybe I'll do this one with an equation just for fun. Because I haven't done that in a little while. So I can insert an equation, make it prettier. One problem with the equation from the right, let's see if that's true, but H naught. If I remember right, if you do colon, it doesn't work. So then what I'm going to have to go, it's kind of a pain. So I go back to insert, then I hit colon, and then I hit insert an equation again. Like I said, have to do it. It's a Canvas issue. Okay, now what letter goes next? So what letter after the H naught colon? Who remembers? I don't see y'all jumping in. The hint is it's a Greek letter. Does that help?
Mu.
Yeah, it's mu. Okay, so it's mu. So I'm gonna make it pretty and make it a nice, pretty Greek letter. All right, and then what symbol after the mu? And this one will always be true for pretty much all of the hypothesis tests. When we have symbols, yeah, equals. And then we wanted to see if it's equal to 25, because that was what the question said. Any questions about H naught? Okay, so now let's do the alternative hypothesis. And with the alternative hypothesis, you have two choices. I really don't care what you do. You could either do HA or H1, whichever you'd like. And then colon, which unfortunately you have to insert equation, then do colon, and then go back to the equation. And then it's mu. Okay, and what inequality is the alternative hypothesis have? What inequality does the alternative hypothesis have for this situation? So hopefully you all got it, because that is important. If it helps, I think I can move this and we can read it. Okay, and it says, wants to see if this average is lower for newborn breastfed babies where the mother lives below poverty. That's a hint. So what inequality? Not supposed to be, it's not supposed to be that tough. Don't see y'all jumping in. Let me read that again. Actually, I think it's not there anymore. There it is. So again, the researcher wants to see if the average is lower. When you see the word lower, what inequality do we write?
Less than?
Less than. Again, there's nothing tricky about it, but you have to read. Okay, and then 25 was our null hypothesis value. And I insert the equation, and there's part A. Okay, by the way, if you write mu instead of, the letter mu, that's fine. Okay, I don't grade on things like that as long as you show what you're doing well. Okay, any questions so far? Okay, part B is state the ramifications of a type 1 and type 2 error. Let's start with the type 1 just because it's first. All right, so if there's a type 1 error, what does that mean? And then what bad things will happen because of it? Any thoughts?
For a type 1 error, did you say?
Yeah, type 1. Okay, I'm just going in order.
The government could end up spending money to help mothers living below the poverty line that they didn't need to spend. Although, to be
Right.
honest, I don't really think that there's ever a bad scenario of helping people who are below the poverty line. But that's
Well, no, but so let me go through how they're going to help them, and that's the key. Maybe they're going to force them to go into training, right? They're going to go into training about how to get their children to drink more. And you've totally wasted all these people's time. And guess what? Now, because they spent all this time on training, they didn't have enough time to work, and maybe they're not making as much money, and they're even poorer. Does that make sense? So we're not saying that they're just going to give these people money. We're saying that we're going to maybe train them and waste their time. Does that make sense? And hopefully you agree that would be bad, right? In every sense. If they're just spending this special training on how to get their children to drink more when they don't need it.
Well, that's something that wealthier mothers would have access to anyway. So that's still like.
No, not with this. With this, that we're giving them unnecessary, maybe mandatory training. So the government ends at sees results of this study, which state that mothers below poverty don't feed their children enough. Or don't, feed is good enough because milk, that's all they feed anyway. They're infants. Enough. So they train the mothers to feed them more. When that is not even needed. Okay, the babies could get hurt because now maybe they're learning how to eat too much, which you got obesity issues. Do you see that? Okay, who knows? Again, I'm not an expert in infant care, but I know with children, if you give them too much food all the time, then they get obese. So the obesity could happen. Time wasted will certainly happen. Right? These are the bad things. You always want to talk about the ramifications. What are the bad things that could happen? Any questions on type 1? Okay, type 2. What would happen with a type 2 error? Okay, it's very different than type 1. So what would the result of the type 2 error be? Any thoughts? Again, different ramifications, different issues. Any ideas? Hopefully you all understand these errors because they're important. You're going to be asked on the exam next week. Okay, think about less action being taken. Yeah, there wouldn't be action taken. So what would happen is the study would not provide evidence that there is a need. So there'll be no assistance offered. No assistance, such as education. For the mothers. Okay, and the babies will be malnourished. I didn't think I'd spell it right. N-O-U-R. So the babies will be malnourished, okay? Which would be bad, right? Any questions on the type 2? Okay, error. Again, we don't have the evidence, but the babies needed more to drink, even though we didn't see it or detect it. Okay. Any questions? Part C. Based on part B, which is worse? So what is our level of significance? So what's worse, type 1 or type 2? Again, they're both bad. And you could decide, again, if you have a good argument, I'll accept it. But you got to have a good argument and explain why. So it's either going to be 0.00, it's going to be either 0.01, 0.05, or 0.1. So what should it be and why? Any suggestions? Okay. Yeah, I mean, I'll go for that. The babies would suffer. So there's more suffering. So let's write that out. I was going to take whatever you guys said as long as you were good. So first is the type error. Type 2 error is worse since the babies or the infants would be underfed, which causes all kinds of issues. Right, problems. All right, so since the type 2 is worse, what should the level of significance be? Yeah, 0.1. Any questions on part C? Okay, for part D, it's find the test statistic and the p-value for the hypothesis test. So now we need the calculator. Can't do this without the calculator. Again, our H naught had a 25 here. We ended up with 23.8. We had a sample size of 41. Sample standard deviation was 7. So let's go to the calculator. Which calculator do I use?
14.
Yeah, this is 14 because it's a mu. Mu means mean. And we have statistics. We have the mean and standard deviation for the sample. We don't have data. So it's 14. S was it 7? Let me look again. Yeah, just want to double check. So S was 7. X bar was 23.8. Good. N was it 41? Yeah, my memory is pretty good. And then mu naught was 25. Any questions on putting in all of the items? Okay, we do want lesson. So definitely keep that lesson. And I hit calculate. And there's my test statistic. Just go a bunch of decimals. So test statistic was T was equal to, why is it lesson? So is your question, why did I put lesson in the calculator or why did I put lesson right here? So I put less than in the calculator because it's less than right here. So the calculator asks you what inequality H1's got. Does that make sense? So H1 is a less than, so that means it's less than. Okay, and that's all it is. It's just, you just write down, you just put whatever H1 is, will be what you get. Okay, and then the p-value. Was it 0.13945-ish? So p-value was equal to that. Any questions on part D? Okay, use the language discussed in Tuesday's webinar to state your conclusion. What are the first couple words? Always for the conclusion. First two words is? So what are the first two words? Yeah, there is. And then statistically. And now the p-value is 0.14 about, which is bigger than 0.1. So that means there's statistically insignificant evidence to conclude that, okay, and now we notice we want to find out, do mothers below poverty feed their infants enough, right? Okay. That was over, here we go. If the average is lower for newborn babies breastfed, if the mother lives below poverty. So I'm just going to copy that. I'm going to put a couple words before that to conclude that the population mean, okay, and that's necessary. Okay, and I guess I should say mean What did I write? Milk drink, fluid drink. What did I write? Ounces drink. Is lower for newborn breastfed babies if the mother lives below the poverty level. Okay, and in fact is lower than 25 ounces. For newborn breastfed babies if the mother lives below the poverty level. All right, I want to interpret the p-value. What's the first word interpreting the p-value? Should be able to quickly put in the chat box since it's just one word, not even a big one. I find the first word is good to get you started at least. And remember, should be quick to type. I don't see y'all jumping in. Okay, maybe I'll, good. If, and then basically the template is if H naught is true. Well, H naught means the population mean amount, let's say ounces that newborn babies with mothers below the poverty level drink is less than, is equal to 25 ounces. Any questions so far? Then there would be and the p-value about 0.14, so 14% chance that, actually, sorry, and another sample of 41 newborns whose mothers are below the poverty level. Is taken. Then there would be a 14% chance that the sample mean for this new sample would be less than, and our number was 23.8. Any questions at all on part F? Okay, for part G, interpret the level of significance. And if you remember, it starts exactly the same. So I copy and paste the first part. If the population mean ounces that newborn babies with mothers, should be mothers, with mothers below the poverty level drink is equal to 25 ounces, and another sample of 41 newborns whose mothers are below the poverty level is taken, then there would be and now it's a 10% chance, because that's what we're used for our level of significance, that the new study would lead us to falsely conclude that and I'm going to copy and paste and change that the population mean, or let's write this way, that newborn babies with mothers below poverty levels drink has a population mean that is less than 25 ounces. And that's the quiz. Any questions at all on any of the parts? Any questions? Okay, I know it's a lot, but the good news is every problem is basically the same. I mean, they're not all milk with, newborn babies, but it's always these steps and the wording is pretty similar. You just got to get used to it and practice. And if you practice, you should get good at it. The only thing we're going to do different today is we're going to be talking about proportions instead of means. Everything else is exactly the same. Okay, it'll be a different number on the calculator, but really there's only one type of problem in this whole chapter. Okay, and sometimes I don't even ask the last couple, but I decided I should for this one, so you got practice. Practice is important. Any questions at all on the quiz?
I was just a little confused from the example from Tuesday. It
Mhm.
was less worded than the one in the question we got today, but
I
it
think
makes
that's
sense now.
yeah, I think that's just because there's no short way of saying newborns whose mothers are below the poverty level.
Oh, okay.
And I think that's the wordy part, but there's no way to say that in 1 or 2 words. Does that make sense?
Yeah.
Yeah, and it's given in the problem, so you can copy and paste. The good thing about computer, the only good thing I think, or maybe one of the only good things about having to take all your tests on the computer is copy and paste saves you a lot of time. Whereas if you, have to write it out on paper, you can't copy and paste. So that's one suggestion I've got for you. Notice I did a lot of copying and pasting. But yeah, there's a lot of words. You're going to find out there's a lot of words in these hypothesis test questions. It's just the way it is. It's not just do a calculation, write the number. It doesn't work that way. Okay, any other questions before we move on? Okay, if not, let's go back to our lecture. And I want to just do a little review. We did hypothesis testing. I might even skip this one for now and maybe get back to it because I want to make sure we get to what we need to get to today, which we should. But I want to mention something about the p-value and the level of significance. Okay, it's one thing to memorize what's going on, but it's even better to understand what's going on. So I have some pictures to look at. And what I did is, what we can look at is the normal curve. And whether you let the mean be 0 or you let the mean be whatever H naught shows, it doesn't matter. If you make it a z-score, then the mean is 0, but you don't need to make it a z-score. That could be whatever number it is. And then there's a lot of things going on here. First is there's a rejection region and a fail to reject region. So if you have, say, like we just did, is a left-tailed test where we had a less than, and if you had, let's say we did 0.05 instead of 0.1, okay? For you, you probably won't mean anything because you probably don't have these memorized like I do. But if you look on the normal curve and you sketch a line so that the area to the left of that normal curve is our level of significance, so 0.05, for example, then there's going to be a value here, like a z-score of negative 1.645. Okay. Any questions so far on that part of the picture? And the idea is that if our samples value is over to the left over here, like right here, then we're going to be what's called in the rejection region. So if our sample value is over here, we're going to reject the null hypothesis. Where the sample value is over here to the right, we'll fail to reject the null hypothesis. And the reason for that is the p-value is the area to the left of that value on the normal curve. So if you're to the left over here, the p-value is going to be small. Do you see that area is real small? Kind of that area in yellow over here that I'm pointing to. So that area is going to be small. It means you're going to have a small probability compared to the level of significance, which is this. So if your probability is smaller than the level of significance, then we're going to say that it's too unlikely to happen. It's too unlikely for H naught to be true. If H naught is true, it'd be too unlikely for what we got to happen. So that's why you're going to say H naught is false. On the other hand, if you're over here, then the p-value is going to be much larger. You're going to have a much bigger area to the left. So you're going to have a pretty big probability of what we got or more extreme happening. And if you have a big probability of what we got or more extreme happening, you're going to say, well, it's not that unusual. There's no reason to say anything went wrong. And if there's no reason to say anything went wrong, then you're going to say H naught, whatever that number was for H naught for mu might be true. And you're going to fail reject. It might be false. It might be true. We just don't know. So this is like the borderline right here, this negative 1.645, where the area is 0.05, for example. And if you're over here so that you're to the left of that borderline, so the area is smaller, that's when you reject. Whereas if you're over in anywhere else out here where it's white, where the area is bigger, you're going to fail to reject. Any questions on that idea? I didn't get a chance to show you the picture last time. I think picture is important. A lot of people are good visual learners, and it's good to kind of see it. Even if you don't like math, at least it's a picture. Okay, if you have a right tail test, which means a greater than sign, then we're in the second picture. So then instead of saying that far left is going to be rare, now we're going to say far right is going to be too extreme because we have a greater than sign. So then if you're over here to the left of this 1.645, you're in the fail to reject region. So anywhere over here, you're going to fail to reject because the area is to the left now, and that area is, the area to the right, and that area is big wherever you are. Whereas if you're over here, the area to the right would be small, and then you would reject. So that would be, this guy is for the right tail test, which is the greater than sign. This one is for the left tail test. Any questions on that? Okay, then there's a two-tailed test. And I think that the picture is worth 1,000 words in terms of why we call it two-tailed. So with the two-tailed test, if you're far on the left or if you're far on the right, you're going to say that's too weird for H not to be true. Because not equal to means left or right is what we're looking for. So if we're left or right, then it's going to be too strange. Notice these numbers are different. We have 1.96 here instead of 1.645 with the other tail, with a left or a right. And that is because if you're talking about two tails, the total combined area needs to be your level of significance. So if our level of significance is 0.05, and the combined area is 0.05, then each of these areas is going to be half of that. So you're going to have to go farther out to make half of that happen. Any questions on that idea? Okay, and then if you're far left or far right, then you're going to say the p-value is too small, and you're going to reject null H naught. Any questions at all on the whole idea, the visual idea of hypothesis testing? Okay, and we've also learned that if you have a pretty large sample size, then it's approximately normal. And if we're talking about a mean, then you have to use the t-distribution because we don't know the population standard deviation, but it still kind of looks bell curve-ish, not exactly, but a little closer to a bell curve. Okay, so on the other hand, what if we have the yes/no question? Then we really do use a normal distribution. There's no t-distribution. So this picture works even better for the yes/no because it really is the 1.96, it turns out. Those numbers are exact, to 2 decimals are perfect. Any questions on this idea before we move on to more to proportions? Any questions? Any questions on any of the steps of hypothesis testing that we talked about on Tuesday? You got quizzed on today, and then we answered it today. Before I move on to proportions, which are the same steps. Any questions? Okay, if there aren't any questions, let's move to an example. That involves proportions. Okay, so here's an example. All right, do the majority of Californians think that Governor Newsom should be recalled? So if you've been following the news, then you know that's a big thing in California right now is, should we recall? All right, what does it mean to be the majority, by the way? We're kind of revisiting this problem because I think we talked about the confidence intervals, but now we're really looking at hypothesis testing. Okay, you're saying 50.1. What about 50.05? Is that the majority?
Over 50%.
Yeah, over 50%. Yeah, so 50.1 will get you in trouble. And I want to give you an example. And this is a very personal example. Okay, do you remember what I told you about myself, my history? About politics? No, if you remember. Maybe I haven't told you. I was a politician for 9 years. Do you know about that?
Yes, you mentioned it a
Yeah.
lot.
In my first election, do you know what my percent was? 50.01. Actually, yeah, 50.01. Okay, did I win?
I mean, wait, how do those elections work? Because I know, was there a runoff?
So what it was, when I say 50.01, I'm saying among those who voted either me or Barbara Banner, that's who I was running against, I got 50.01% of the vote.
So you won. But
And
was
I
there
won.
a runoff?
Huh?
Was there a runoff?
No.
Okay.
No, I got the majority. I won. Okay. I was shocked because the newspaper said I lost, and I believed them. Be careful what you read in the news. A week later, they called me up and said I won. But so I want to note that 50.1 is not the cutoff for majority. 50% or below is not a majority. Anything above 50% is a majority. So very important. I see that mistake a lot where people will put in a 50 point something or 51%, and that's not the borderline. The borderline is 50% for majority. So the majority of Californians think that Governor Newsom should be recalled. Okay. Suppose that 341 of the 674 Californians surveyed answered that Governor Newsom should be recalled. Run the full hypothesis test. How is this different than what we did on Tuesday and on the quiz today? How is this different? Yeah. So what's different is this is a yes/no question, right? The survey question they're going to ask people is, do you think Governor Newsom should be recalled? And you only have the choice of yes or no, and that's it. And when we have the yes/no question, that means that we are talking about proportions and not means. Any questions on that first? Okay, another question is, our sample size large enough to use a normal distribution? So let me just start there. For the sampling distribution. Is it large enough? How do you tell? Because if it isn't, then we can't answer the question at all. Can't even do a hypothesis test. So
What
is it large enough?
5 or something?
Yeah, and what's the it? What number? Yeah, so larger than 5 is right, but what larger than 5 in this case? Okay, good try. Not 674. There aren't a lot of other choices right now, at least for the first one. Okay, well, actually it's not 341. It's because this majority is going on. 50% is what H naught is saying, and if you take 50%, so if you take NP 674 times 50%, which is 0.5. Then that's 337 if you do that in your head. Which is certainly greater than 5 by a lot. Also, 674 times, we can do NQ now, and that is 1 minus 0.05, 0.5. Well, 1 minus 0.5 is still 0.5 in this case. We just got lucky. So that's still 337. And that is greater than 5. So that means we can proceed. Okay, that means when we use the calculator, it'll work. Otherwise, we're doing this wrong and you can't do this. Any questions so far? Always good to check that your sample size is large enough. And if you have proportions and your sample size is not large enough, there's no assumptions. You just give up. You can't do anything. You give up or you get a bigger sample. Those are the only choices. All right, so now that we know our sample size is large enough, we need to write down H naught. Okay, and the hint is it's not going to be mu this time. What is it going to be this time? Very easy to type in the chat box. So what letter are we using now for the parameter? Not a hard question. Shouldn't be, at least. Seeing that in the last chapter, we had to kind of answer the same type of question. So what letter do we use? We have a yes, no question, survey question. We got that figured out. Yeah, P. Typically lowercase p, but I'll give you what you wrote. So P equals.
It auto-corrected.
What's that?
It autocorrected the capital.
Oh, as an autocorrect. Oh, I hate that.
Yeah.
Yeah, I get autocorrected all the time. I don't know if you've noticed when I'm typing in here too. Yeah, yeah. So P equals 0.05. And now let's write down H1. We're going to have a P. What inequality? And it's kind of written out, but you have to be able to read it right. So H naught is P equals 0.5. H1
Greater
is
than 0.5.
is what?
Greater?
Yeah, greater than. Because majority means more than. So greater than 0.5. Any questions? Any questions on getting H naught and getting H1 written out? Any questions? All right. What about a type 1 error? Let's assume that maybe CNN is doing the study. Because it's important to know who's doing the study to think about what damage will happen with a type 1 error. So what is the damage or the ramifications of a type 1 error?
Then CNN will say that the majority.
Well, let's just post an article. They don't say anything, they usually post. Or actually, sorry, for me, it's always post an article. Will because for you guys, you probably watch it on TV. I always just read. So we'll, yeah, say that what?
That Governor Newsom should be recalled, but really.
Yeah, yeah. Or let's say the Californians think that Governor Newsom should be recalled.
Oh, yeah.
But what?
When it's split 50-50, right?
Yeah, when there isn't a majority. Okay, and then what will end up happening to CNN?
They'll lose credibility.
Yeah, they lose credibility. People will stop trusting CNN. So CNN will lose credibility. Okay. And that's bad for a news station, right? People no longer trust them. And we'll go to another. News station for their news, right? Because if CNN is just wrong, then why would you listen to them? You're just going to turn them off and you're going to listen to someone else. That's bad for CNN, isn't it? How about type 2? What'll happen with type 2? So it's very different in terms of ramification. So what will CNN do now?
They won't say that. They won't say that the majority of Californians think that he should be recalled.
Yeah, and in particular, they won't even air it. discussion about how Californians feel about the recall. Okay, now if you don't show the news when there is news, that's not good either, right? So then people will go to a different station. So a different news channel to get their news. Do you agree they're both bad? Right? If you can't even find out about something when you watch CNN, you're not going to watch CNN anymore. When some other news station actually got it and they talked about it and they convinced you and then they were right, but CNN wasn't. Okay, CNN didn't even bother because they didn't have evidence. Okay, which is worse? Is type 1 worse? Is type 2 worse? Or are they about the same? What do you think?
Say they're about the same.
Yeah, these were similar. Read the last sentence. They're like the same outcome in the end. You know, the reason for the people not going watching CNN is different, but they're both bad for CNN. So what should the level of significance be? So since the type 1 and 2 errors have about equal damage, let the level of significance be what? So in our class, what do we use if they're about the same?
0.5, 0.05.
0.05, good. Yeah, level of significance is 0.05. Alpha is 0.05. Any questions on where we are at this point for this example? Are you noticing that this is very similar to what we did on Tuesday? Same steps, same reasoning. The symbols change a little bit from U to P, but do you agree that just step by step, it's exactly the same? All right, do you remember what the next step was after choosing what the level of significance was? Do you remember the next step? Nobody remembers?
Test statistic and p-value.
Yeah, test statistic and p-value, use your calculator. It's going to be slightly different, but nothing significantly different. So if I go to the calculator, which calculator do you think I'm going to use?
$16.
Yeah, 16. We're doing a hypothesis test. There's an H, not an H1, it's clearly a hypothesis test. And we had a P. We had a P equal and we had a P less than. P stands for proportion. There's a hypothesis test for proportion. Any questions on it so far? It asked for n. So let's go back. What was n?
$74.
Yeah, 674. So 674. It asked for x. What's x?
341.
Yep, 341. It asked for p naught. So what is p naught?
.5.
Yeah, 0.5. We haven't actually seen p naught before, but when you have a naught, that means a number with h naught. P equals 0.5. So 0.5 is p naught. All right. Is it less than, greater than, or not equal to? Move it over here. Is it less than, greater than, or
Greater.
not equal to?
Greater.
Yeah, it's greater than because that's our H1. H1 had a greater than sign. So I go greater than. And hit calculate. Okay, notice, by the way, the test statistic is Z, not T, with proportions. There is no student's T distribution, it's just normal. And I'll just look at it. How about 0.3081? So we have our test statistic was Z equals 0.3081. And our p-value was equal to 0.3790. Any questions on finding the test statistic and p-value? Okay, so I'm trying to convince you that this really is the same as what we've been doing all along, and did on Tuesday. I mean, there's a couple very small differences, but it's the same. So the idea is, the hope is, by the time this week is over, you'll have a good way or good feeling and good practice on doing hypothesis testing. Okay, and by the way, next week we do more of it with some more tweaks. All right, so now what's the conclusion? And to decide on the conclusion, the key is we're looking at the p-value and we're looking at the level of significance. And how do we decide how to conclude when we see a p-value of 0.3790 and a level of significance of 0.05? What's important? 0.05. What's important about those two numbers? So what's important, and again, it's exactly the same as what we did on Tuesday when you have a p-value and a level of significance. What are we doing with those two numbers? How do we use them? What's important? I don't see you all jumping in. It's the same thing we did on Tuesday. Okay, what's important is that 0.3790 is greater than 0.05. And when the p-value is greater than the level of significance, we fail to reject. the null hypothesis. Any questions on that? Okay, so this is the same as what we did on Tuesday. All right, so when you fail to reject the null hypothesis, the conclusion is there is statistically insignificant. And I mentioned before, sometimes you'll say there is insufficient evidence. That's another way of saying the same thing. Insignificant evidence to conclude that, and now you just restate H1, that the population proportion of Californians who think that Newsom should be recalled is greater than 50% or more than 50%. So in other words, there's not a majority. Okay, but that doesn't mean that we can say there's not a majority. We just don't know if there is or isn't. It might be that there is a majority, but our sample size is too small, so we didn't get the right answer. Or it might be that there just isn't a majority. We really just don't know. Any questions at all on the conclusion? And it's what I like to do is I'm going to make it a little bigger because that conclusion is the most important part of the whole test, right? That's what you're, if you're going to publish a paper, that's what you're going to publish. You're going to say, yeah, the population proportion or the proportion of all Americans that think Newsom should be recalled. We really don't have an indication whether it's greater than 50% or not. Any questions at all on this conclusion? All right, now that we got the conclusion written, how about interpreting the p-value? And the idea is the same idea as Tuesday, except now it's going to talk about proportions instead of means, but same thinking. So if we want to interpret the p-value, which was about 38%, we would say that if, big word if, so if exactly 50% of all Californians think that Governor Newsom should be recalled, and we surveyed another 674 Californians, then there would be and the p-value is 38%. The idea is 38% is not some very small probability. It's not surprising if that happens when it's a 38% chance. There would be a 38% chance that at least, and what we got was, it's in here, 341. Of the sample would think that Newsom should be recalled. Any questions on interpreting the p-value? extra wood. Any questions on interpreting the p-value? Okay, I do want to let you know, you need to be able to write this stuff out next week on your exam. So you're going to have to do, it won't be about Governor Newsom. It'll be about something else. But the point is you need to understand how to get this written. And the really, instead of listening to me and say, yeah, I understood what he said, practice it. Write down your own examples. Okay. And I recommend typing it in a computer so you get used to doing it the way you're going to be doing it on the exam. So let's interpret the level of significance. And the idea, copy and paste. All the way up to there would be A. So if exactly 50% of all Californians think that Governor Newsom should be recalled, and we surveyed another 674 Californians, spelled wrong. There would be A. Well, now the level of significance is 5%. 5% chance that the new study would lead us to falsely conclude that, and now we would say over 50%. Okay, and I'll even say that the majority, it's a nicer way of saying it, of Californians think that Newsom should be recalled. Any questions on interpreting the level of significance? Okay, any questions on this whole process when we're talking about a proportion instead of a mean? Any questions at all? This is your chance because it's very important. If you're confused about something, you want to ask now so I can help you out.
Will there be questions like this on the homework for this chapter?
So let me tell you the big difference in the homework and the exam and the quizzes is because computers can't read an answer like I just wrote, it can't ask you to type all this out. Does that make sense? Because it's not going to know if you got it right or not. So it'll be multiple choice. It'll give you like 4 different interpretations. And you have to pick one, which one is right.
It doesn't really prepare us to be tested on the material when it.
Right. So let me tell you. So let me give you a suggestion. Yeah, you asked a good question. Let me tell you how to prepare yourself. So you're going to be given on the homework something like this. It'll start like this. Okay, it won't be about Newsom being recalled because we wrote this way before we even knew Newsom was going to be governor. And then it's going to go through each of the steps with a lot of multiple choices. The only thing it won't do multiple choice is the p-value and the test statistic. It's going to have you type in a number. So here's what you should do. Read the question and then do everything I just did without looking at the rest of the problem. You have to be able to do that. Okay. Some people have self-control and some don't. Hopefully you have enough self-control not to move your eyes down and read the rest. So in other words, read this part, do the whole hypothesis test, and then go answer the question. And the hope is that you should be able to answer all the questions at that point. Does that make sense? And that's how you can practice for the exam. Because again, computers, the AI isn't quite good enough to be able to handle that yet. Maybe in 20 years. So next generation. All right, what I want to do now, it's 5:05, is take a break because I like to make sure we get a break. So I'm going to stop. I'm going to mute and we'll come back at 5:10. Okay, it's 5:10, so let's come back. Hopefully you got a nice little break. And I'm going to share again. I think I want to do one more example. So just a note, by the way, if your computer is going to die, it's not the end of the world today. Just note that this will be recorded. It's always posted. But when you take the exam, don't let your computer die. Make sure you're prepared for that. That's very important. So let's read one more question that I've got, and this is an example. Has the proportion of all Americans who think that COVID is the most important problem gone down? Okay. And unlike the last example, this one actually got data from Gallup. Gallup just surveyed 961 Americans. 20% of them said COVID was the most important problem. That compares to 25% a month before. It looks like it went down, right? 25 to 20. So did it go down? Let's see. And I'm going to do the main parts of this. I'm not going to do the last two pieces. First thing is, what is our H naught? What's our H naught in this case? And the hint is we're not talking about a majority anymore. So what is H naught?
P equals 0.25.
Yeah, so P equals 0.25. Because note this is a yes/no question. Okay, we're surveying people saying, do you think COVID is the most important problem? People say yes or no. That makes it a P. Always think about the survey question. That's number one. If you get that wrong, then you'll get everything else wrong. So it's very important to get that down. Okay, and notice this is not a confidence interval question. Okay, because that's another thing when you get to the exam, you have to know is it a confidence interval or is it a hypothesis test? And this is clearly hypothesis test because we're just asked a question. Has it gone down? Not how much has it gone down, or estimate how much it's gone down. That would be different. That would be a confidence interval. Okay, so H naught, P equals 0.5. And then we have H1. And what's the inequality? P is?
Less than
Yeah,
0.25.
Yeah, less than because gone down. Those are the keywords. You always want to look for the keywords. And here is, has it gone down? Down is small, means it went smaller. So less than 0.25. Any questions on that? Okay, and I'm going to quickly say it. You got 961 in your survey. 25% of 961 is definitely over 5. It's over 100, in fact, way over 100. And 75%, that's Q, of 961 is also well over 5. So there's no problem. We can actually use a calculator. Any questions so far? All right, so now that we've got that, what we can do is go to our calculator. And we're going to use the same calculator. That's the good news. Okay. By the way, if you want to erase everything, you just hit refresh. And that just puts all the boxes blank. And that way we can start over again. Okay. And what we have is N is 961. We have X. So X, we have to do a little work on. X is going to be 20% of 961. And that's 0.2 times 961. Okay. So we can actually go over here and scientific calculator. Go 0.2 times 961. And you get 192.2. Always use rules of rounding in this kind of thing. So we have 192. P naught, that's on the other side of the P with the H naught, and that's 0.25. We do want less than. We hit calculate. So notice that the Z, the test statistic, is about, I'm going to say 3.6, negative 3.6. And the p-value was equal to 0.00016. Okay. By the way, I didn't even decide, what my level of significance was. So if nothing's talked about, then use 0.05. That's standard, but it actually doesn't even matter what we use because this is such a small p-value. The result's going to be exactly the same. So in this case, notice that this is less than anything that we care about, but 0.05. So the conclusion is there is statistically, is it significant or insignificant?
Significant.
Yep, significant because of a small p-value. Okay, you want small p's. Okay, if you go to a restaurant and they give you peas as a side dish, you don't want giant peas. That'd be disgusting. You want small peas. Okay, anything to help you remember. That's my feeling. So there is statistically significant evidence. To conclude that, okay, and we look at the population proportion. Of all Americans. And I can copy and paste. Who think that COVID is the most important problem has gone down. Any questions on the conclusion? Any questions? Okay, I'm actually going to stop here for this example. I'm going to pretend that that's all I asked for because, as I mentioned, the conclusion is a biggie, and I want to make sure that that's the one you always write. Sometimes I'll ask for the others also, but the conclusion will always be asked. Okay, so that's the biggie. Any questions on this example? Okay, I'm going to do one more kind of example. And I want to show you what research looks like. So this is the title of an article, and I'm going to actually kind of show you also how you can actually find articles. It's just not a statistics thing. It's just a college thing. And if you go to our library, you go to find articles. If you go to academic search complete, it's going to ask you for your username and password. That'll be whatever you use in Passport. Hit login. And this is the title. I'm just going to show you how to search for something. I want to show you what articles look like. What does research look like? There we go. And if I hit full PDF full text, I can actually read the article. One of the nice things about our library is that it subscribes to basically all articles, which is kind of nice. So, or most research articles. So you can get research articles and you have to pay. Whereas if you were doing this, on your own and you didn't go to our college, so you didn't have that password, then it's going to be very expensive. So it's kind of a nice thing. So this is it, the relationship between perceived psychological distress, behavioral indicators, and African-American female college student food insecurity. This is an article, and I'll just let you know that if you go and look at research articles, most of them will have the hypothesis test. is standard. The interesting thing, any guess on what field, if you're looking at research articles, what field is the least likely to show hypothesis test and p-value? And it's very ironic. That's a hint. Any guesses? No guesses? Okay, it turns out the one field where you won't see hypothesis tests, or very rarely, is math. Because we're not okay with 95% confidence and 5% level of significance where we might be wrong. Math, you have to prove something, and proofs are absolute. Math is really the only subject where you don't have to do a hypothesis test. But every other subject that I've ever seen, most research articles will do it. So let me just show you in this article. I know the font's kind of small. It's just kind of the way with Zoom. That's kind of what we got. So I'm not going to read this whole article to you because it'll take all day long, but I want to show you where it gets into results. Okay, so if you go into the results, they even give a table. This is very standard. And demographics, etc. But then if I keep going, it does independent t-test. Remember the t-distribution that we're talking about? So if you read through this, as shown in table 2, differences in psychosocial and behavioral inventories and food insecurity status were assessed using independent t-tests. Participants with food insecurity were significantly more likely. So there's that statistical significance. Okay, to have used drugs in the last month. Okay, and they say 2.25 versus 1.53. And then they just say P is less than 0.05. Okay, they don't even need to state the conclusion because they can assume that everyone reading a research article, not talking about news article, research article, gets what P is less than 0.05 means. Okay, so anyone reading this knows the conclusion just by seeing it. Okay, and you'll see they did others. Here's the low self-esteem beliefs. Actually, P is less than 0.01. So that's strong, significant evidence. Okay, and then they go here, they just put a star or an asterisk or double asterisk or no asterisk. And then in the asterisk, they talk about what the p-value is. And notice, for example, for family connectedness, then they didn't have significant evidence to show there's a difference. So all through this article, you're going to see lots and lots of discussion on p-values. And I'll let you know a lot of the tests they use are more advanced than we know yet, but we'll be getting those later. And some we won't get, but you might get it someday. But if you look at the conclusion in the article, all over the place, they give you the test statistic, they give you the p-value, they talk about that there's significant evidence. Any questions on what a research article looks like? Okay, and I didn't just like go find the one that worked best, and I had to look through 100 articles to find one. I think this is the second one I looked at. And the first one had some p-values, but this one was a little better. So the point is that this is everywhere. And if you can't handle hypothesis testing, then you're not going to be able to handle reading research. And being an upper division college student, a lot of that is about reading research. Okay, it's going to be expected of you. In any field you get into, you're going to have to be able to read research. So hopefully you believe me. I didn't just pick this article because it was the one. They all look like this. Okay, they're all this way. In fact, I even had to help my brother once. The one article he had to write for medical, actually, he's a doctor. He got my help about p-values, and I helped him with the p-value because he had to write the article. He wanted to make sure that what he was doing was right. Turned out he was doing it right, but he wanted me to help him, kind of word it perfectly. But the point is that no matter what you're doing, anytime you write a research article, you have to talk about the p-value and a hypothesis test. Any questions on this idea? All right, so if there's no questions on that, then what I want to go to next is the syllabus. And it's not coming for a while, but it's worth it to talk about now. Next week, we're going to be busy. So what's going to be, other than we're going to do another chapter, chapter 10. And then what's the other big focus on Tuesday? Because I want to announce this. What am I going to be talking about on Tuesday?
The final?
Exam review.
Yeah, exam 2, not the final yet. Final's a while from now. The exam 2 review. So I want to make sure I have time for that. So that's why I can't talk about project 2 next week, because I want to make sure we're focusing on the exam. Okay, so project 2 is not due until June 8th, but you know how time flies. You know, it'll come at you. Right now it's only the 20th. So you have a lot of time before the project, but don't wait till June 7th, please. That'd be a disaster. Okay, you want to get this going. So it's June 8th is when your project is. And I want to remind you another thing, very important. And that's right here, 30% penalty will be incurred on any student who cannot work with another student. Okay, this project has to be done just like project 1 with a partner, or even better, 2 partners, 3 in a group. So if you don't have a partner, put it in the chat box. I'm looking for a partner. If there's only 2 of you and you want a third, put in the chat box and maybe you'll find someone right here. Okay. But this is a good time to go look for partners. Okay. And hopefully you'll find partners. Okay. And if you haven't communicated with your partner from project 1 and you're just assuming, make sure you communicate. So you make sure that you still have your partner and your partner is okay working with you and your partner's still in class and all that. So that's real important. You must have a partner for the project. Any questions on that first? Okay, then let me click on project 2. Okay, so I want to give you a little note, and that is I'm not ready to talk about all the details of project 2 because project 2 focuses on the next chapter, but the next chapter is not that much different than this chapter that we're in now and last week's chapter. So it's really a chapter 10 project, but when we get to chapter 10, and that's why I can do it in one day because we have a test on Thursday, that it's not that different. So that I want to give you that disclaimer before I continue on. All right, so let me let you know the purpose of project 2 is confidence intervals and hypothesis test. Okay, that's the purpose. So don't get project 2 confused with project 1. Okay, project 1's main purpose was to understand good sampling techniques, to understand statistics, mean and standard deviation was a biggie, and then the mean and the quartiles, understand charts and how to draw beautiful histograms and stem and leaves and all that. Don't focus on all that stuff for project 2. Okay, a lot of people are tempted to. You're wasting your time if you spend a lot of time in any of that. Okay, and when I read it, I just I don't take off points, but I just glance through it fast if you have that stuff. On the other hand, confidence interval and hypothesis testing. And that's what the project is all about. Okay. Like project 1, you have to identify a client, okay, that might be interested in what you're doing. Okay. You don't really have to find a client. That's hypothetical. Okay. If you want your client to be Newsom, or if you want your client to be Biden, for example, that's fine. Doesn't mean you have to go, talk to Biden. Be cool if you could, but good luck. But you can pretend it's Biden, okay, or whoever it might be. Okay, so a client that would be interested in what you're doing. Any questions on that piece? Okay, your study is, as I mentioned, the next chapter. The next chapter is about comparison tests. Okay, so you're actually going to be doing a comparison study. And we'll talk about that next week. So I will let you know about that piece of the project next week, but it's going to be a comparison test, which means you're not ready today to fully design your project because we haven't talked about it yet. So I want to get to at least the points that you do need to understand. And one of that is timeline. So on Tuesday, which is not too long from now, we'll learn about chapter 10, and that's when you'll be ready. Okay. And I would say probably within the next 7 days of that Tuesday, so a week and a half or so, you and your partners should have your project idea developed. Any questions on that step? So again, step 1, make sure you have partners. Step 2, get your project idea. Step 3 is to let me know, and that could be in class. Okay, it could be email, whatever. Let me know what your project idea is, and I can help you with it. Okay, and I'll let you know. And what I'll probably do is a week from Tuesday, I'll probably spend a little bit of time, maybe at the end, focusing on that, where you can talk to me and we'll just chat, okay, as a group. And it helps to hear what other people are doing too, so you can get the ideas. And that's why it's a good chat as a group. So that's something you want to do, is have that ready. Any questions on that? Again, you don't want to wait till the last minute. Okay. Then once you've done that, what you're going to do is you're going to collect your data. Okay. So once you have a project idea and you've run it by me and I said, great, or here's a couple little changes you need to make. Hopefully that's all. And by the way, it's going to be quantitative. As we've seen last week, if you have a yes, no survey question, you need to get thousands of data points, or at least 1,000. And I think that'd be evil if I did that to you. So I'm not going to. That's why quantitative over 30 is our big number. Okay, so then after that, you're going to collect your data. So I want to really emphasize something, and that is this is not project 1. Project 1, you're required to have a representative sample, either using cluster sampling or stratified sampling. Project 2, you do whatever you want to do. Convenience sampling is allowed, just as long as you write about it. That's all I care about. As long as you say how you did your sampling. Okay, but you can do the easiest kind of sampling. I don't want you to spend all the time just on sampling. The other big difference between project 1 and project 2 is project 1, the requirement was you had to do a survey where you asked people. With project 2, you don't have to do a survey where you ask people. Any ideas of what I mean by that? Right? How could you collect data without asking people? Any thoughts? Kind of a quiet group. I don't see any of you jumping in. Should I give you some examples? Okay, so let me give you an example of what someone did last quarter. It was a good project. They looked at, they wanted to see, their hypothesis was that Amazon was cheaper than kind of smaller companies. Okay, So they wanted to see if that was true or not. Okay, but I'm trying to remember. Maybe they thought it was more expensive. I don't remember which one it was. So, don't quote me on whether it was cheaper or more expensive. So what they did is they just went to the Amazon website. They typed in a product, and a product, I don't know, might be surfboard. Looking to find out how much surfboard is on Amazon. And then they went to Santa Monica Surf Store online, looked to see what they charged, and they wrote it down. Do you see that? They didn't have to ask anyone. They just went online and found the data. Okay, let me give you another one that people have done, and that is, I think I mentioned Snapshot Day on Tuesday. Not sure if I mentioned that or not. It's hard to remember because I know I did for the online class for the other section. I might not have for you guys. So on last weekend, I participated in Snapshot Day, not as a statistician, just as a kind of community member, which is where we collected data of the creeks that went into Lake Tahoe. So you might think that maybe this decade is different than the decade before. Okay. So if you look at the last 10 years versus the 10 years before, maybe the pH, there's a difference in the pH, maybe not. Okay. So you can get the data by just emailing or, asking for it from the Keep Tahoe Blue, which is in charge of that, and they'll send you a spreadsheet and there's the data. Okay. If you could get an entire population, which you couldn't get in this case because it was just data collection, then that's not okay, by the way. So if it's easy to get the whole population and the population is not that big, then that's not an okay project. Okay, so because if it's easy to get and the population isn't that big, there's no reason to do a hypothesis test or a confidence interval because you could be 100% confident because you can get the whole, if you can get the whole population, no reason to do a sample. Any questions on those kind of examples? Okay, you are allowed to survey if you want to, but it's just usually more work. And the rules, kind of the requirements, are the legal rules still apply for Project 2. You're not allowed to survey children because that's against the law. And I don't want to go to jail. You don't want to go to jail, so don't do that. Okay, so no surveying children. And the other one, in terms of rules that apply, what was the other rule? What were some of the others? So you can't have, if you can get the whole population, it's not okay. That's another big rule. And no surveying children. Any questions on that idea? Okay, so that's the next step. The next step is you collect your data. Okay. And actually, before you collect your data, what did we do? What do you have to do before you collect your data in the steps on hypothesis testing? And it could be all part of your kind of project planning and ideas. What was the one thing? And here's a hint. It was one of the parts. Actually, it was two of the parts on the quiz you took today. That happens before you collect your data. Being kind of quiet.
Identify the null hypothesis.
Okay, so that we already talked about basically, because that's what you're gonna chat with me about. Will that work? Does that make sense? Your null alternative hypothesis. So you're right about that. You identify the null hypothesis. You identify the alternative hypothesis. And that's the talk to me. Is it going to work?
Oh, okay.
So what's the next step? And the hint is it was the next step on your quiz. Here's the hint. There are two things, a 1 and a 2. That's a hint.
The ramifications of a type 1 and type 2 error.
Yeah. Yeah, so before you collect your data, you should look at a type 1 and type 2 error. And then based on that, decide on your level of significance. That needs to be done before you look at your data. Okay, you should never choose your level of significance after you look at your data. That's actually what they call unethical, it turns out. Okay, so once you've done that, then you go and collect your data. And then after you collect your data, what are you going to do? What do we do?
Find the test statistic and p-value.
Yeah, you're going to find the test statistic and p-value, but differently. And when I say differently, I mean you need to, and I think I showed you this on Tuesday. At least I reminded you that it was going to happen. Sorry, I got to move my Zoom stuff to get there. Just a second. You're going to go to the statistics spreadsheet. Okay. And I think I've mentioned this before. You go to the statistics spreadsheet. And the reason I require a spreadsheet is that some universities require it for transfer. And if this doesn't transfer, then I haven't done my job. So I make sure that it's part of the class so that I can tell them, yeah, they use a spreadsheet. And they say, yeah, this transfers. Just let you know that. Then, so there's a spreadsheet, and there's the same spreadsheet you use for project 1. And so you don't have to recopy it. It'll still work. But what you're going to do, because now we're going to be later in the class next week, we're going to hit this 2var stats. Okay, and I'll show you this next week on all the details. We're not there yet because that's what next week is all about, on how to understand this stuff. But then you're going to put your data in and you're going to read it. It's easy to use, but you just got to use a spreadsheet. And then just like project 1, you're going to copy and paste the piece of the spreadsheet that's relevant into your project. Any questions on that? So you can type that in. You're going to get confidence intervals. You're going to get a p-value. You're going to test statistic. The other big thing you're going to get, let's say you're doing what's called dependent sampling, is you're going to get a standard error. The standard error is the main statistic that you have to fully analyze. Now, remember, there are a lot of things about the standard error, and I don't know if you've thought very deeply about it. First thing, remember, the central limit theorem says the standard error is basically the mean divided by the square root of the sample size. And if you have a big standard error, then that means your sample mean is not going to be a great estimate for the population mean. Whereas if you have a small standard error, that means you do have a good estimate. So you're going to have to make that analysis as a good estimate or not based on the standard error. If you have a poor estimate, so for example, then, if your standard error is big, then that means your sample size could have been bigger. And you talk about it. Doesn't mean you're actually going to make a bigger sample size, but you should talk about it in your project. Similarly, if you have to decide on the level of confidence. So here, for example, it says 0.9. You could change that to 0.95. You could look at it. And it changes the lower and upper bound. You can change it to 0.99. And that changes the lower and upper bound also. And you should weigh the pros and cons on that. And if you're not able to be happy about the combination of your confidence level and the confidence interval spread, the margin of error, then that means your standard error is too big. Whereas if you are satisfied with your level of confidence and the margin of error, then your standard error is small enough and you don't need to do another study with a bigger sample size. Okay? because the only way to get your standard error smaller is a bigger sample size. We talked about that a few chapters ago. Any questions on that so far? Similarly, if you look at the hypothesis test, and if you're not happy about your p-value, so let's say you did a right tail test and you got 0.38, then that means your standard error was too big. When are you happy about your p-value? When are you good with your p-value? Who remembers? We talked about that on Tuesday. Okay, if you don't remember, maybe I'll say it. We don't have that much time left. So if your p-value is small, you reject the null hypothesis and you accept the alternative hypothesis. Your goal is to accept the alternative hypothesis because you're trying to publish something. And if you accept the alternative hypothesis, you get to publish. So if your p-value is smaller than the level of significance, then you say the standard error was great. It was small enough. I got what I wanted. Okay, if the p-value is larger than the level of significance, then that means you fail to reject the null hypothesis, right? When you fail to reject the null hypothesis, it could be based on two different reasons. Do you remember what the two different reasons for failing to reject in terms of the reason why you ended up having to? Can you remember that? Okay, I don't see jumping in, so maybe I'll mention it. So one reason is that your sample size was too small. Your alternative hypothesis was correct, but you didn't ask enough people or you didn't take enough data. And in that case, you're usually going to get a p-value that maybe 0.06, really close to your 0.05 if that's what you chose. And in that case, you're like, oh crap, man, I think I'm still right. I'm not able to show it. Maybe if I have a bigger sample size, then I can make it happen. Okay. The other thing that could happen is maybe you're just wrong. And if you're wrong, your p-values tends to be really big, like 0.38 or 0.9 or something like that. And then it's hopeless. And you don't say, well, it's the standard error's fault. Standard error might be small enough, but the problem is you're just wrong in terms of your alternative hypothesis. So then it's time to give up. And don't say I'm going to do a bigger sample because that's just going to waste your time anyway. Then you can get even bigger p-value. Okay, so those are the two reasons. So if your level of significance is, p-value is really, really large, you give up and you don't blame it on the standard error. You don't say I need a smaller standard error by getting the bigger sample size. Instead, you just give up. Whereas if p-value is like 0.06 when you had 0.05 for level of significance, you say I need a bigger sample size. Standard error is just bigger than I want it to be. I can get it smaller, and hopefully that'll give me the ability to reject. Any questions? Okay. For the project, you don't actually do a bigger sample size. Just talk about what you would do next and why you would want that bigger sample size. So notice the standard error by itself has meaning. It has meaning with the confidence interval. It has meaning with the hypothesis test. Any questions on that? Okay, just a note. I have a whole video on the standard error in this project. Watch it. It'll get you an idea because it's usually the hardest part for the project for most people, trying to understand the standard error. So I'll let you watch the video. Okay, so again, the main thing is confidence interval hypothesis test. And like project one, your audience is your client. Okay, you're not there to write down all the equations for statistics. You're there to explain how each of the items that you found will help your client make decisions. And what decisions might your client make based on the lower bound for the confidence interval, the upper bound for the confidence interval, the p-value, the conclusion of the hypothesis test, the standard error. Okay, for each of those items, talk about what decision and how your client will react to the item. And that is the main part of your project throughout the entire paper, not just at the end. Any questions on that? Okay, so again, I'll let you read through all this. I'm not reading, you have this so you can read through, but it has all the different things you should have. And again, the biggie confidence interval, hypothesis test, that should be most of the paper. I have a link, I think, in here somewhere. So I didn't see it. If not, I'll make it happen before you're ready anyway. With Zoom, things are hidden. It's at the bottom. Oh, it's not there yet. There will be a link to suggestions I made on Project 2 in the past. So it's not there yet, but it will be. This goes to an older version of the project description. Sorry about that. So that is your project. And what I'm going to do is stop the share. And I'm going to stop the recording.